I'm going to talk about rhombuses, squares, and trapezoids. Now, if you're not familiar with quadrilaterals, parallelograms, and rectangles, you may want to watch my videos on those topics. Okay? Let me start with definitions. Rhombuses are parallelograms with all four sides congruent. Squares are rectangles with all four sides congruent. Trapezoids are quadrilaterals with one pair of parallel sides. Let me give some examples of each. Okay, so a rhombus, we know that it's a parallelogram, so opposite sides are parallel, and we know also that opposite sides are congruent. Now for a rhombus, it's not just opposite sides that are congruent, but all four sides are the same length as well. Okay, there's one example of a rhombus. There is another example. Okay. And then squares. Squares are rectangles with all four sides congruent. You may recall that rectangles are parallelograms with right angles. So squares have all the properties of rectangles in addition to having all four sides the same length. So there's two examples of squares. And then trapezoids are quadrilaterals with one pair of parallel sides. Okay, so in that example, I have two horizontal sides that are parallel. Now, if you have a pair of opposite sides that are parallel, and if the other pair of sides are congruent, but not parallel, that's referred to as an isosceles trapezoid. All right? So an isosceles trapezoid is a trapezoid such that you have a pair of parallel sides and the other pair of sides are congruent. So this is an isosceles trapezoid. All right? Now, let's try to prove some assertions using these definitions. So I will state three assertions and invite you to try to prove them. Prove that rhombuses have diagonals that are perpendicular bisectors of each other. Okay? There's one. And then here's another one. Prove that isosceles trapezoids have congruent base angles. Think about that one. And then one more. Prove that isosceles trapezoids have congruent diagonals. actually, you know what? Let me add a square proof as well. Prove that squares are rhombuses. All right, so pause the video and try to prove these assertions if you like. All right, I'll go ahead and show you one way to prove these. So let me, for the first one, let me draw a rhombus. All right, and let me also draw the diagonals of this rhombus. And let's recall some properties we know that this rhombus has. So we know that all the sides are the same length. We also know that the opposite sides are parallel, so we have congruent alternate interior angles where the diagonals are the transversals with respect to the parallel opposite sides. So let me label some congruent alternate interior angle pairs. Okay, now we've got 4 triangles that have been created inside the rhombus. Okay, notice that we have congruent triangles as well. So if I label this triangle triangle 1 and this one triangle 2, then I know that those 2 triangles are congruent by the ASA theorem. Therefore, I know that I have these 2 sides congruent, and I have these 2 sides congruent. The reason I know that those two sides of those triangles are congruent is because I know that corresponding parts of congruent triangles are congruent. I sometimes refer to that by this acronym, KIPTIC, I call it. Okay, so KIPTIC gave us all that information, and notice that the diagonals that the point of intersection is the midpoint of both diagonals. So we've shown that the diagonals are bisectors of each other. Now let's show that they are perpendicular bisectors of each other. Okay, so using KIPTIC, we can also show that the remaining 2 triangles are congruent to triangles 1 and 2. And so therefore, all of the angles in the center of the rhombus are congruent. Okay, and the 2 of those right angles form a straight angle. All 4 triangles form 2 straight angles. The only way that that can be true and all 4 angles be congruent is if they are all right angles. Okay, so that proves that the diagonals are perpendicular bisectors of each other. Okay, now let's go to the second one. Prove that isosceles trapezoids have congruent base angles. Okay, so let me start by drawing an isosceles trapezoid. And let's recall what we know to be true about an isosceles trapezoid. We know that we have congruent sides and we have parallel sides. The other pair of sides are parallel. Okay. Now, because the 2 horizontal sides are parallel, that means that that means that I can draw a line that's perpendicular to both the top and bottom side. Okay, and every line segment that has endpoints on the two parallel sides will be congruent. So in other words, these two are congruent. Another way to see that those two vertical line segments are congruent is because in order for two line segments to be parallel, they have to be the same distance apart everywhere. Okay? So also I said that those vertical line segments were parallel to the top and bottom horizontal sides, so that means we have right angles formed. Okay? And now notice that I have two right triangles. And I know that those two right triangles are congruent from the HL theorem. That corresponding hypotenuses are congruent and a corresponding pair of legs are congruent. Okay? And then by Kiptich, I know that all corresponding sides are congruent. Therefore, the base angles must be congruent. Okay, and I hope you were able to think of this argument or one that's just as good, if not better. Okay? And then now let's go to the third one. Prove that isosceles trapezoids have congruent diagonals. So let me draw a new trapezoid and we will talk about it. All right, so an isosceles trapezoid, remember, has one pair of sides congruent and another pair of sides parallel. Okay, and let me go ahead and draw the diagonals so we can have an example to talk about. All right, so for this example, it's going to be helpful to label the vertices of the trapezoid. So I'm going to call the vertices A, B, C, and D. Okay? Now I want you to focus on two triangles that I've just drawn in the picture. Okay? Triangle B, D, C, and triangle A, C, D. Okay? Notice that both of those triangles share the bottom side. They also have have another pair of sides that are congruent because AD is equal to BC. Okay, and furthermore, we know that the base angles of isosceles trapezoids are congruent. Okay, so therefore, I know that those two triangles are congruent using the SAS theorem. All right, so because we know that they're congruent, we can use Kiptich to assert that AC is equal to BD. Therefore, the diagonals are congruent. Okay? And so now let's go to the last one. Prove that squares are rhombuses. All right, so what has to be true for something to be a rhombus? Well, it has to be a parallelogram, and all four sides have to be congruent. So a square certainly has all four sides congruent. Is it a parallelogram as well? Well, we know it's a rectangle, and we know that rectangles are parallelograms, therefore squares are also parallelograms, therefore squares are rhombuses. Okay? Now let me close by giving you the area formulas for rhombuses, squares, and trapezoids. Okay? So remember that we measure areas by counting the number of a standard sized square that we need to cover the area. Okay? And you may recall that the area of a rectangle is equal to the product of the length and the width. If I call the length L and the width W, the area of the rectangle is LW. Okay? Now, a square is a rectangle. Okay? Therefore, I can just use the rectangle formula. Let's say that this square has a side S, side of length S. Sides all of length S, right? Okay? So the area of that square is length times width, or S times S, so S squared. Okay? Let's derive the area of a rhombus now. So let me draw a rhombus. Okay? And let me also draw diagonals. Okay? And we know that the diagonals of a rhombus, we proved that they're perpendicular bisectors. Okay? So we've got right angles, and we know that all four sides of the rhombus are congruent. So we have four right triangles that are all congruent, right? So the area of the rhombus is not going to change if I move those right triangles around. Okay? Let me label the triangles 1, 2, 3, and 4. Now, if I kept 2 and 4 where they are, but I moved 1 and 2 to where these red right triangles are, I would form a rectangle. Okay, so just to be clear, I'm taking triangle 1 and I'm moving it right where the red one triangle is. I'm taking triangle 3 and I'm moving it right where the red 3 is. Okay? So now, to calculate the area of the rhombus, I can calculate the area of this tall rectangle instead. And I know that this tall red rectangle will have the same area. Okay, all I did was move pieces of the rhombus somewhere else. Now, let's suppose that the diagonals of the rhombus had, let's say that the diagonals had length D1 and D2. So let me draw D1 and D2. So let's say this is D1 and the rhombus, the other diagonal is D2. Okay, so the length of the red rectangle, the long length is D1, and the short length of the width of the red rectangle is D2 over 2, right? So therefore, the area of the rhombus is D1 times D2 over 2. All right, now, last but not least, let's do the trapezoid. So let me start by drawing a trapezoid. And this doesn't have to be an isosceles trapezoid. We want a formula that works whether it's isosceles or not. Okay, so we'll assume that the top and bottom sides are horizontal and parallel. Okay, and I can draw a line from one vertex to another side that's parallel to the side on the left. Okay, now I'm doing that in order to create a parallelogram. Okay, so I've divided the area of the parallelogram of the trapezoid into a parallelogram and a triangle. Okay, now so let's use the formulas for the area of a parallelogram and a triangle and add those together to derive the area of a trapezoid. So let's say that the trapezoid had top and bottom base lengths B1 and B2, and let's say it had a height h. So let me label those h, B1, and B2. Okay, so we know that the area of the parallelogram is 1/2 times, or excuse me, is the height times the length of the base. Okay, the length of the base, the top and bottom of the parallelogram have a length B1. So the area of the parallelogram is B1 times h. The area of a triangle is 1/2 base times height. Okay, the base of the triangle in my picture is the difference B2 minus B1. So 1/2 base times height becomes 1/2 times B2 minus B1 times h. All right, and now let's simplify that equation. And so we get B1h plus 1/2 B2h minus 1/2 B1h. I can combine the terms that contain B1h and factor out the 1/2, and I will get 1/2 B, this is the area of a trapezoid, I'll get 1/2 B1 plus B2 times h. Okay, so let me just to, like I did with the other ones, let me write it in blue with A equals formula. So for the trapezoid, we have A equals 1/2 times the sum B1 plus B2 times h.